Dear students, today we'll study the protective devices used in an electrical system. The protective devices are necessary to protect electrical appliance or equipments against the different possibility of short circuit or overloading of equipments, abnormal variations of the supply voltage, and also to protect the operator or human beings against the accidental contact. There are different types of the protective devices we're studying in this particular session, that is fuse, miniature circuit breaker, as well as earthing. First we'll see what we mean by the protective devices. The protective device for electrical circuits have got two main functions. One you call as the consistency, and the second one is what you are calling as the protection. That is, the consistency means you have to give the reliable electrical supply to the consumers without interruption. Therefore, in the event of the fault, the circuit should be protected against the accidental changes in the system, abnormal conditions such as short circuit, overloading of a equipment, or abnormal variation of the voltages. It should be cut down so that we can protect the equipments in the system. At the same time, as soon as the fault is cleared, once again you have to resume the supply by connecting it. That is what you are calling as the consistency as well as the protection of the system against the abnormal conditions. The protection assured through the detaching the power supply in the circuit through a overcurrent protection, which removes the fire hazards as well as electrocution in the system. That is, when there is a abnormal condition occurs, the main function of the protective devices is that you have to detaching the power supply from the circuit. The properly protecting system or equipment is a key step in reducing the costly downtime as well as equipment damages. That is, you can reducing the costly downtime, that is what you are calling is the downtime, then uptime, then based on that we are defining the reliability index. Therefore, you have to minimize the downtime by cutting down the system under fault condition. You have to clear the fault and once again resume the supply. And at the same time, you have to protect the equipment against the damages. These are the two important function of the protective devices. The protective devices are necessary in the system because it has to protect the electrical appliances or equipment against the different abnormal conditions such as short circuit, abnormal variations in the supply voltage, overloading of equipment, as well as to protect the operator against accidental contact with the faulty equipment. There are different types of protective devices that are used in the electrical system. The one is the fuse wire, or simply it is called as fuse. Then the second device what we are using in the protective device as the MCB, it is called as a miniature circuit breaker. Then there is a earth leakage circuit breaker, that is called as ELCB, and in some time we are using the combination of ELCB as well as the MCB for better performance. And the most importantly, there is a provision of earthing or grounding in the system. These are the protective devices you are using in the electrical system against protecting against the abnormal conditions. Then why are the circuit protective devices are important? That is, the protective devices are important because they ensure that under the fault condition the high fault current cannot flow, as well as protecting the installation. More importantly, ensure that the consumers are not injured or killed as a result of an electrical fault. Main thing is to protect the equipment as well as you have to protect the human beings for the electrical shock. The overcurrent protection is provided by the different equipments. that is the circuit breakers or fuse or the earthing. The conditions are arises in the system because of overloads or a short circuit. An overload is a result of the faulty item or too many items being connected to a circuit. That is what we are calling is the overloading of the system. A short circuit occurs when a live conductors come into contact with an exposed conductive part, that is what we are calling is a dead short circuit, or another conductor in the circuit where is a very low or negligible impedance, so that it is what we are calling the dead short circuit. Because of that the heavy current will flow. This is to protect the system. We need the circuit protective devices. That is the importance of the protective devices in the electrical system. The first device that what we are using to protect the system against the short circuit current or the overloading is by means of a fuse. The fuse and a circuit breaker are one of the critical components of the electrical system, while both circuit breakers as well as the fuse perform the same job, that is to prevent the overload or a short circuit. Then we'll see how exactly the fuse, then what do you mean by the fuse, what is the function of the fuse. The fuse work on the principle of heating effect of the current. Fuse is always connected in series with the electrical circuit, that is the fuse is connected in series with the appliances as well as the supply. Then when this fuse is designed so that it has to take the normal operating current under healthy condition. If it is exceeding that current, that is the rated current what you are calling, then what happens? The current which is this fuse is designed, then what happens? Because of the heavy current there is a heat is producing. Because of the heat is producing, there is a blowing up of the fuse. Because of that there is a disconnection of the supply to the load, so that you can protect the load against the high current. That is a fundamental principle on which the circuit breaker works. The fuse work on the principle of heating effect of the current. Fuse is always connected in series with the electrical circuit. When the excessive current or heat is generated due to the heavy current flow in the circuit, the fuse melts down due to the low melting point of the element, and it opens the circuit and protect the equipment. This is a function of the fuse in the system. The construction of and working of a fuse. A general fuse consists of a low resistance metallic wire. The fuse is nothing but low resistance metallic wire enclosed in non-combustible material, that is porcelain material. That is, this is the fuse is connected. This is here, thus there is supply is given at this point, and at this point there is a load is connected. In between these two there is a connection, what we are calling is a fuse, or a low resistance metallic wire is found between these two lines, so that there is a continuity. In the event of there is any fault, there is a blowing up of this part, then there is a discontinuity of the supply to the load. It is used to connect the install in series with the circuit and device which need to be protected for the short circuit and overcurrent. Otherwise, electrical appliance may be damaged in case of absence of the fuse or a circuit breakers, as they are unable to handle the excessive current. If you are not used the fuse or a MCB, then there is an effect on the load or the appliances because of the excessive current which is flowing in the system. Then the second, the protective device, what we are looking here is the miniature circuit breaker. The function of the circuit breaker and the fuse is the same, that is, it is a breaking the circuit in the event of a abnormal condition. We'll see a miniature circuit breaker automatically switches off electrical circuit during an abnormal condition of the network, means in the overload conditions as well as the faulty condition, it is disconnecting the circuit. At the same time, once the fault is cleared, then it is a restoration is very easily possible using the circuit breaker. Therefore, restoration is easily possible by just switching it on. In the event of the fault, then circuit breaker automatically goes into the off position. Once the fault is cleared, once again you can bring back to the its on position. But that is not the possible in the case of the simple fuse, that is it is blown out. You have to replace that the fuse in the case of the fuse. The working principle of the MCB, it is very simple. Whenever the continuous overcurrent flows through the MCB or miniature circuit breaker, there is a bimetallic strip which is heated and deflects by bending. This deflection of bimetallic strip releases the mechanical latch. There is a mechanical latch. The mechanical latch is connected to a contactor. That contactor will detach from the fixed point. As this mechanical latch is attached with the operating mechanism, it causes to open the miniature circuit breaker contacts and the MCB turns off, thereby stopping the current to flow in the circuit. That is, there is a mechanism. It is a consist of the bimetallic strip, as well as there is a mechanical mechanism with the movable contact. Because of these three combination, there is an opening of the circuit breaker under the overload condition. At the same time, normal condition can bring back just switching on the circuit breaker. Then how exactly the circuit breaker works, that you can see here. There are two contacts here. I told you there is a one contact, that is what you are calling is a fixed contact. This is what you are calling is the moving contact. A pair of contacts can be found inside the miniature circuit breaker. One of them is fixed and the other is moving. This is a fixed contact. This is the movable contact. It is under the normal operating condition. It can be switched on. There is a knob here. You can make it manually on or off. Even under the healthy condition also, you can break the circuit by just switching off this. Then under healthy condition, see here, this is a wire, it is connected to load. The current, this contact is connected to the supply. The current is entering here, it is passing through this, then it is passing through this. This is what you are calling a bimetallic strip. This is called as bimetallic strip. This is a spring, and it is a mechanical mechanism. Okay, in the normal operating condition, the current will flow here. It is flowing through this, and it is connected to here to the load. When the heavy current will flow because of the abnormal condition, what happens? This mechanical strip, a bimetallic strip, is get expanded. Because of that, the lever is moving here. This lever is moving down. When lever is moving down, then because of this spring, you can see here the portion of the spring here, what they are getting here, then it is moving, it is pulling this movable the strip towards this. Therefore there is a disconnection here. Therefore there should not be any supply is flowing through the load here. Therefore under abnormal condition, it will heat it up. Because of this heating up of that, there is a mechanism is moved here, then thereby there is a movement of the movable strip from the fixed contact. Thereby there is a opening here, thereby there is a breaking of the circuit between the fixed contact and to the load. Thereby there is a working of the circuit breaker. You can see here, this is the fixed contact, this is a movable contact. Because of this mechanical movement or a mechanical system, then it is pressing this lever here, thereby there is it is pushing here, therefore there is a discontact of the contact between the moving as well as the fixed contacts here. This is some of the figures of the miniature circuit breaker shown here. Then if you are comparing the fuse and the circuit breaker, they have got a same function, but while operating and design is somewhat different between the fuse and the circuit breakers. The fuse works on the thermal electrical property because of the heating up of the circuit element or a fuse element, there is a breaking of the circuit. It is working on the switching principle and electromagnetism. There is a lever mechanism. It is working on a lever mechanism. Then it does not give any indication of the overloads. It is not giving any indication. When there is the current is exceeding a certain limit, then because of the heavy current, then if there is a heat is produced, because of that the fuse will blow. But in the case of the circuit breaker, it gives an indication of the overload, thereby you can switch it off or automatically it is switched off. Fuse can only be used once. That is, one if you are wired up the fuse, it can be used. Once it is blown up, once again you have to replace by a new fuse. A circuit breaker can be used many number of times. When it is under faulty condition, if it is goes off, after clearing the fault, you can switch it on once again. Provides protection against the power overloads, provides the protection against the power overloads as well as the short circuit. It detects and interrupts the fault circuit condition. It performs the interruption process only then the fault are detected by, in this case, is the relay system. The fault is detected. The performance of the MCB is to only to break the circuit, but the signal what we are getting from the relay system. Then it is automatic in the operation, can either be automatic or manually. Then it is operating in 0.002 seconds, whereas it can be operated in 0.0 to 0.05 seconds. If you are comparing the cost, it has got a low cost. The fuse is very, very low as compared to the high cost. That is the circuit breaker. Then, what do you mean by the electrical shock? The electrical shock is the pathophysiological effect of an electrical current through the human body. Its passages affects essentially the muscular, circulatory as well as respiratory function and sometimes result in serious burns. The degree of danger for the victim is the function of the magnitude of the current. If the magnitude of current is heavy, it is more effect on a human body. That is what we are calling is electrical shock. When the current exceeds the 30 milliamperes, passes through a part of a human body, then the person concerned is a serious danger. Therefore, you have to protect against the electrical shock. If you are not interrupted immediately in a short time, then there is a serious problem to the human beings. Therefore, you have to make the devices such that accordance with the national standards, statutory regulations as well as code and practices. Then there are two types of the electrical shock you are getting by means of direct contact of the live wire or the indirect type. Indirect means it is a failure of the insulation. This is a direct current, contact. A direct contact refers to a person's coming into contact with conductor which is live in normal circumstances, whereas in the indirect contact refers to the person coming into the contact with an exposed conductive part which is not normally alive but has become alive accidentally, that is because of failure of the insulation. Then you have to protect the human being from these two direct contact shock and indirect shock. In this case, there is a protection by insulation of live parts, protection by means of barriers. In the case of this indirect, we have got two level of protection. One is earthing of all exposed conductive parts, and level 2 automatic disconnection of supply in the case of the fault. Based on this, we are designing. What do you mean by this? The earthing. The earthing is the process of through which instant discharge the electricity move to the earth's plate. Then you can see here there are, if you are not making earthing, there is a direct the flow of current to the human body, whereas in the case of earthing there is it is taking a low resistance path through the earthing and it will go. That does not affect the human beings. There are two types of earthing they are made here. One is called as the plate earthing. Here you are using a plate as a earthing material, whereas in the case of the rod. These are the pictorial view of the earthing. Coal salt is provided to make the resistance less, whereas this is the plate earthing. Thank you for listening patiently. This is about the protection of the human being by the electrical shocks.